Okay, so the next section that we are going to see in this lecture is called as differential operators. So let us see what is meant by a differential operator. So we are going to denote capital D is d by dx, means the derivative with respect to x. D square will be represented by the double derivative, so d2 by dx square, and so on. So in general, what is dk? D power k is the kth derivative of the function. Okay, so d power k. So this now what I will do is I will take these derivatives and put them in a combination. So what I will do is I will take constants. Suppose I take constants a naught, a1, a2 up to an. I'm taking these as constants which are real numbers. And what am I doing? I'm going to take the constant a naught and multiply by the nth derivative. So d power n plus next constant a1 multiplied by the n minus 1th derivative, and so on. And the n minus 1th coefficient an minus 1, I'm going to multiply by only one derivative, plus the last constant is an, which has no derivative. This combination I'm going to call a. Okay, we will understand this by an example. What is the meaning of this? This a is called the differential operator. This capital A is called differential operator of order n. So let us take one simple example to understand what is this. So I will write a equal to 2d square plus 3d plus 1. Okay, so this here is representing like a naught. This is your a1 and this is your a2. So three constants. So what are a0, a1, a2? They are real numbers. Namely, what are the real numbers? 2, 3 and 1. So A is a differential operator of order 2. Operator of order 2. Now what is AY? What is AY? What is AY? AY is equal to, let me write it. What is A? A is 2d square plus 3d plus 1y, which is equal to 2d square y plus 3dy plus y, which is equal to, what is d square? What was d square? D square was d2 by dx square, right? So let me see what is d square. d square is only d2 by dx square. So I will go up to 2 d2 by dx square y plus 3 d by dx. What is capital D? It's d by dx y plus y. This is the expression for ay. Okay, I hope it is clear. Let me take one more example. What is one more example? What is a equal to? Suppose I say x d plus 3. Okay, what is ay? What is ay? So solution, ay is equal to x d plus 3 y, which is equal to x dy plus 3y, which is equal to x dy by dx plus 3y. This is an expression for ay. Okay, do you observe that there is a difference between the above ay and this ay? And one of the important difference in the above ay and this ay is that this ay is a differential operator. Okay, and what are the coefficients of the derivatives? The coefficients are here, they are constants. Okay, but what about this ay? The coefficients are not all constants. So one of them is constant, ये तो constant है, but this is not a constant. So it will mean that this a is, I'm going to call a differential operator. Basically what we have defined here above is what? This a, now if we are taking all the coefficients as constant real numbers, so this a is called a differential or operator of order n with constant coefficients. With constant coefficients, because a naught, a1, a are all constants, but they can be functions of x also. Okay, in this case, for example, in this case, this a is a differential operator. This a is a differential operator with variable coefficients. With variable coefficients. Okay, now what we will learn is, if I have two operators, I'm going to take two operators like a, and I'm going to take one more operator, and I'm going to multiply them. I'm going to try to multiply them. So what am I trying to go? I'm going towards the algebra part. Algebra means what? Addition, multiplication, so on. So if I take a simple exercise, let me suppose take a is equal to d plus 2. All of you, I mean, understand the meaning of d plus 2 now. D plus 2 means d by dx plus 2. And I'm going to take b equal to, suppose I'm going to take 3d minus 1. Okay, and I'm going to find two things. I'm going to find ab, and I'm going to find a plus b. Similarly, I can find a minus b. And I'm also going to find ba. Okay, I'm going to find these four things. Now it is clear that a plus b is d plus 2 plus 3d minus 1. So this is easy. I mean, this is not a just 4d plus 1. Similarly, you can calculate a minus b. So you can do this. So addition, subtraction is not a big deal. Let us calculate what is AB. Now to calculate AB, what I will do is I will, instead of finding AB, I will find what is ABY. What is AY? Which is A of BY, which is equal to A. What is B? B is 3D minus 1y, which is equal to A 3 dy by dx, because d means derivative, minus y, which is equal to, what is A? A is d plus 2. D plus 2, 3 dy by dx minus y is equal to d into this plus 2 3 dy by dx minus y, which is equal to 3 times the derivative of dy by dx is d2y by dx square minus the derivative of y plus 6 dy by dx minus 2y, which is 3 d2y by dx square plus 5 dy by dx minus 2y, which can be written as 3 d2 by dx square plus 5 d by dx minus 3, sorry, minus 2, and the y I have pulled out, which is nothing but 3. What is d2 by dx square? Now our notations tell us that d2 by dx square is d square plus a 5 d minus 2 y. And who was this person? This was AB y. And therefore what is AB equal to? So AB is equal to 3d square plus 5d minus 2. Now after doing all this lengthy calculation, what I understand is that if I have AB, what is A? A is d plus 2 into 3d minus 1. If you simply solve this also, d into 3d is 3d square minus d plus 6d minus 2, which is 3d square plus 5d minus 2. So this is AB, which is the same answer as we have done the detailed calculation here above. Okay, so I can even do this. So this, the second part that I showed you, this second part, this is much simpler, faster and easier to do. And therefore if I want to calculate BA, I understand that if I multiply 3d minus 1 by d plus 2, and again if I do the same calculation, I will get same 3d square plus 5d minus 2 the same. So I will get AB and BA both are the same. So AB and BA are both the same here. So here AB is equal to BA. And multiplication is a normal multiplication. It's not a different type of multiplication. Okay. But now let us take one exam. But so don't be under an impression that if I take two differential operators A and B, then AB is always equal to BA. Okay, so don't be under. So let me take one example now. So yes, I can say that AB is equal to BA. So two differential operators A and B give the calculation AB equal to BA only if there is something special. We have to observe what is that special. So let me take one more exercise so that the idea will be clear. Suppose I take A equal to xd plus 2. As soon as I have written A is equal to xd plus 2, you must have noticed that this A is an operator and the coefficient is a variable coefficient, and B I'm going to take as d minus 1. Now here you have to be little bit careful. You cannot do the calculation that we did above. You just cannot directly multiply them. It will give you something wrong can go. So let us see that is AB equal to BA. Okay. Here what have I noticed? The coefficients are variable. They're not all constant coefficients. There is some variable coefficient in the operator. So let us calculate AB by our old method, which is AB y is equal to xd plus 2. B is what is B? D minus 1 y. So पहले हम we will solve this part. So it is xd plus 2 into this will be dy minus 1. What is dy minus 1? Dy minus 1 means
dy minus y, sir.
dy minus y, thank you, which is dy by dx minus y is equal to xd into dy by dx minus y plus 2 into dy by dx minus y, which is equal to x d2y by dx square minus dy by dx x plus 2 dy by dx minus 2y. Okay, which is same thing to say that it is x square. This will give me just 1 dy by dx. Okay, so this is d2y by dy dx square plus this is dy by dx minus 2, and this I'm going to put a y outside. So this is looking like, who was this? This was ABY. So it is x square d square plus d minus 2y. So this is the answer of AB. Okay, now when I go for calculating BA, I have to be little bit more careful. So when I have BA of y, it is equal to B of AY, which is equal to B. What is A? A is x plus xd plus 2, which is equal to, what is B is d minus 1. So d minus 1 of x y, I forgot the y, x dy plus 2y, which is d, this d can be replaced by what? Dy by dx, which is equal to d into x dy by dx plus 2y minus 1 times x dy by dx plus 2y, which is equal to, now the derivative of, so here I'm having what? The derivative of x dy by dx plus the derivative of 2y. Okay, I'm purposely writing this because I want to go a little bit slow because I'm doing it for the first time. Minus x dy by dx minus 2y, which is equal to, now what is the derivative of x dy by dx? So I will have to use my product rule here. So x as it is into the derivative of the second term. What is the derivative of the second term? It is d2y by dx squared plus the derivative of the first term is the derivative of x is 1, so I'm not going to write it. So 1 into the second term as it is, dy by dx. Okay, so I'm erasing this one, minus x dy by dx minus 2y. Okay, and then I will pull out the y common. So I have x d2 by dx square plus d by dx minus x into d by dx minus 2 of y, which is equal to x d square plus d minus x d minus 2 y. This xd, this is x into d, means x into derivative. No, it is not derivative d into x. Okay, d other derivative of x will become 1. Okay, so this x is not on the right hand side. Be careful. Otherwise, you will say that's a dx to 1 ho jata hai, because derivative of dx is equal to 1. So we have to be careful. It is x multiplied by the derivative. So at the most I cannot simplify this now. At the moment we can take x d common and 1 minus x minus. This is at the best thing you can do. So this is, I might have gone somewhere wrong in my calculation. Please, sorry if I have went wrong somewhere, but I see this. Oh, fine, okay. So I don't worry now. So so this means that AB and BA are giving me two different answers. Why this came up to be? The reason is that uh, the operators were with which type of coefficients? They were with variable type of coefficients. That is the reason we got that. I think I forgot in this calculation. I forgot this person. Okay, I'm sorry. Right, this gave me two things. I forgot plus 2 times d by dx. I'll just correct it if I have understood my mistake. 2 I forgot. So यहाँ पे this will become 3 times because 2 and 1 is 3. So this will become, I think, 3. Please check, all of you. And this is, I hope this is 3. I think now this is correct. Yes. So AB is not equal to BA. What is the reason behind this? The reason is that the coefficients are variable. Correct. So A and B had variable coefficients. So one has to be careful about constant coefficients and variable coefficients. If the coefficients are constant, then AB and BA are always equal. Okay. Now, what we will do is we will see some properties of this differential operators. Let me write some properties. If you carefully notice that if I'm having d square and then I'm having d cube, okay, what is this coming up to be? So I know that d square and d cube of y is nothing but the second derivative and then the third derivative of y, which is basically the fifth derivative of y. So the property I'm having is this is nothing but d raised to 2 plus 3 because this is the fifth derivative of y. So what am I trying to observe in general? What am I trying to say? In general, dm dn is equal to d raised to m plus n, where m and n are obviously positive integers. Okay, or you can take even zero derivative. Zero derivative means do nothing. So this is one of the simple properties that we observe for the operator D. Some second different simple property that I observe. Now, if you carefully see that what is d of e raised to mx? What is d of e raised to mx? Means that I'm asking you the derivative of e raised to mx. And the derivative of e raised to mx is equal to m e raised to mx. Okay, so what is the derivative? What is the second derivative of e raised to mx? Which is e raised to mx का second derivative लिया तो first derivative will be m into e raised to mx, and if I again take the derivative, it will be m into e raised to mx, which is m square e raised to mx. Correct. So do you observe some relation now? What is the cube? What is d cube e raised to mx? Then I will have obviously m third times derivative will give m cube e raised to mx. So what am I trying to tell you in general? In general, I'm trying to tell you that if I take the kth derivative of e raised to mx, I'm going to get it what? I'm going to get it m raised to k e raised to mx. This is the second simple property that we observe, where k is again what? K is some positive integer, including you can also take the zero derivative, right? Now what I will do is I will take a polynomial. So let f of d be equal to, now see all of you see this is very easy. Let me take an operator which is f of d. I'm going to take a naught d square. Let me put it a2 d square. Let me put a2 को d square, a1 d and a naught. This is what is this? This is a differential operator. Differential operator जिसको हमने previously capital A बोला था. Okay, so this is a differential operator, and that differential operator is depending on what? It is depending on the d. It is depending on the derivatives. And what are a naught, a1, a2? A naught, a1, a2 are constants, real numbers. Now let me calculate what is f d e raised to mx. Can I calculate what is this? So just substitute, which is a2 d square plus a1 d plus a naught e raised to mx, which is equal to a2 d square e raised to mx plus a1 d e raised to mx. D means derivative, so don't be afraid of d. A naught e raised to mx, which is equal to what? Which is equal to a2. What is the double derivative of e raised to mx? We have already calculated. The double derivative of e raised to mx always comes to be m square e raised to mx. So this is m square e raised to mx plus a1. What is the derivative of e raised to mx? M e raised to mx plus a naught e raised to mx, and this is equal to what? This is, if I pull out the e raised to mx term common, e raised to mx, what will I get inside? I'll get a2 m square plus a1m plus a naught. Okay, and now who is this particular person? Who is this person? The person in the bracket. Okay, who is the person in the bracket? Who is the person in the bracket? You see, what is fd? Fd is f of d is a2d square plus a1d. Okay, sorry. What is f of d? F of d is a2d square plus a1d plus a naught. So if instead of d, if I write m, what will this look like? It will look like a2m square plus a1m plus a naught. So this is the person in the bracket is nothing but what? F of m e raised to mx. So what we have proved in this particular above thing is that fd. What is f of d? F of d is a differential operator. What is f of d? F of d is a differential operator. If you have a differential operator with which type of coefficients? With constant coefficients, then what is f of d e raised to mx? What is f of d e raised to mx? F of d e raised to mx is equal to f of m e raised to mx. So we have proved this for using the above criteria, where what is f of d? Where f of d is a differential operator with constant coefficients. Okay.